Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Thank you, Margaret. I think also in these sort of moments of reflection after Her Majesty's death, actually, we can also take a moment to remember people of our own community, like Brian, and the amount of contribution he made to our whole industry. Anyway, it's enough of that. We've got enough black ties and things. So, the Carbon Conundrum. So, how can we further reduce the impact of our schemes? Over the past decade, the traffic systems manufacturers have made strides in reducing the energy consumption of traffic equipment. The switch to modern electronics and LEDs has had a transformative impact on electrical consumption of installations, with many types of equipment providing 80% or more savings when compared to traditional equipment. This process is also ongoing. As an example, with currently emerging LED products looking to achieve 1 watt traffic signal aspects compared to 50 watts for traditional halogen or say 10 watts for current LED type products. However, in the coming few years, reliance on electrical savings will not be sufficient in its own right. Steve Elderkin, the Director of Environmental Sustainability at National Highways, recently said that achieving net zero will be part of everyone's role. So we will need to continue to reduce the environmental impact of our installations to a level that aligns with the goals set in the COP26 Glasgow Climate Pact in November 2021. And although the net zero requirements is not mandated until 2050, many organisations are either already carbon neutral or actively working towards that, with a view to attain net zero by 2040, so such as National Highways maintenance and construction goal. This also needs to be viewed in the context of the fact that road transport as a whole accounts for over 10% of global greenhouse gas emissions, and the total emissions are rising faster than any other sector. Because of this, the transition to zero-emission vehicles, ZEVs, is of vital importance. But intelligent transport systems infrastructure cannot rely on this to offset overall savings in the sector. The ITS element also needs to step up to this challenge. Infrastructure as a whole is responsible for around 53% of the world's greenhouse gas emissions, of which nearly 20% is attributed to the embedded emissions from infrastructure, i.e. the manufacturing, the construction and life cycle management of the infrastructure assets. We've seen that significant savings have already been made and continue to be made on the operational side of our sector. But the embedded carbon caused by the civils construction and the manufacture, installation of equipment also needs to be addressed. As an illustration of the impact that construction has, if the cement industry is compared against national emissions, it would actually be the 3rd largest global emitter after China and the United States. Unfortunately, though, with the pace of technology change, which is anticipated for the sector over the coming decades, the certainty the industry had for planning infrastructure requirements is now far more problematic, leaving it difficult to establish a reliable roadmap for equipment requirements in coming years. This stems from the anticipated benefits that both connected and then automated vehicles will provide. Because of this, the ability to build in longevity and to future-proof installations is now more difficult to justify because of the long-term uncertainty about the requirement for equipment. I don't think that we need to worry about flying cars just yet, though. The paradox to this all, though, is the growing anticipation and reliance on technology to overcome issues such as capacity constraints to provide alternative solutions to the construction of new features, such as new or widened roads. Traffic signals will also continue to play a vital role, including promoting and managing active transport modes, but especially important for vulnerable users. To facilitate achieving carbon savings, a carbon reduction hierarchy should be adopted. This provides a framework around which both strategic and specific decisions can be made. So, the first of those is build nothing. Therefore, the starting point to reduce carbon begins with assessing if new infrastructure is actually required. Could the operation of existing assets be optimised or repurposed to achieve the desired outcomes instead of building a new installation? So just as we heard at the start. And could we adopt new safety tweed jackets maybe? I don't know. The next step is to build less. If we do need to construct something, can we rationalise it to reduce the impact? For traffic signals, this will look to justify the requirements for each new pole and cabinet. This will need to balance user safety of the finished installation, but by not ending up with a surfeit of equipment, this obviously also provides benefits of minimising street furniture clutter. So, very simplistic example of this, 2 poles or 4 poles for pedestrian crossings. The next step, build clever. One of the biggest areas for improvements in infrastructure construction is the adoption of circular economy techniques within the materials supply chain. Traditionally, the linear economy would extract natural resources, turn these into a product, and then discard them at end of life. We're not going to get away from using materials like concrete, but by using non-virgin materials, preferably renewable, in these results in considerable carbon savings. And then build efficiently. Wastage of materials and resources is an endemic problem when constructing infrastructure. It is still common for a large proportion of brought-in materials to be wasted and not used in the finished asset. Although the traffic signals sector was an early adopter of using modular and factory-produced equipment, this is an area where more thought will need to be applied. As an example, precast concrete products can provide confidence in repeatable quality owing to being produced in a controlled factory environment, achieving a huge reduction in waste. So, going forwards, we need to consider how the lifespan of existing infrastructure can be extended when equipment updates and replacements are required. Because of the earlier foresight of practitioners across the industry, most traffic signal installations use fully ducted systems with pole retention sockets, so simple signals renewals can usually make use of these with minimal need for replacement. Specifying low-carbon products should be integrated into projects from the very start, rather than being afterthoughts. Alternative concrete mixes are becoming more readily available, using recycled aggregates and alternatives to Portland cement. It's now possible to produce concrete with 80% lower embodied carbon compared against traditional specifications. Alternatives to traditional steel poles can offer much longer life expectancies at moderate additional costs. For example, expected lifespans of 50 years are often claimed for aluminium poles. Although aluminium made from bauxite is much more energy intensive than steel production, many of these products are actually made from recycled materials, which is far more energy efficient. Alternatively, maybe we could plant some trees to hang equipment on. Designers will need to think about how they design so that at the end of life, Installations are easier to disassemble and demolish, facilitating efficient recycling of materials. As an example, polypropylene chamber boxes are recyclable, but this is very difficult if they are encased in concrete. Where precast concrete products are used, these usually incorporate lifting eyes, so these could also be used to remove them, allowing the possibility for them to be used again or to be efficiently recycled at a specialist centre. It's expected that technologies will evolve which will provide even greater emissions reductions over coming years. As this sector matures, leaner construction techniques which reduce waste, new end-of-life materials and waste management processes will make use of more digital solutions. But we can't just sit back and wait for these to come. The replacement of diesel power plants and generators will also make a contribution to reducing the footprint of our construction projects, whilst also reducing noise, nuisance and pollution to nearby residents. In order to quantify and report the success of carbon reductions, the use of a carbon calculator, such as Mott MacDonald's Moata Carbon Portal, will allow designers to make informed decisions for their projects. The direct integration with BIM software and the bill of quantities enable efficient calculations to be undertaken up to 90% faster than using manual methods. Many of us have already started our journey to net zero. As a founding member of Net Zero Infrastructure Industry Coalition in the UK, Mott MacDonald is already carbon neutral and is actively working to achieve net zero by 2040. Thank you. And lastly, whilst I still have your attention, this year's QR code is for the ITS Now YouTube channel. So if you'd like to impress friends and family with what you've been doing here in Nottingham this week, there's some great videos on there. One about the history of detectors and an explanation of how push buttons work. Anyway, thank you very much.
Thank you, Alistair, for keeping to time and presenting such an interesting presentation. That's a really good start. Thank you.
Thank you, Margaret.
Questions?
Stunned everyone into silence. Excellent. I've escaped lightly.
I'll start with one then.
Okay.
You talked about, the decarbonising. Your model, the estimator for carbon emissions, does that look at the whole life cycle of products?
Yes, it does.
So you've got the embedded carbon of each component?
Yes. So, these things typically use a model for each product, each item. So for infrastructure, items are put together in models for particular types of installation. And they tend to be fairly generic to start with, but then we can actually focus it to actual requirements for construction projects. So typically at the moment they're used on massive schemes and projects, but I think more and more we'll see this sort of thing being used in a more routine basis on smaller and smaller projects.
Is the estimator freely available? Is it open source, or do colleagues have to pay for it?
Yes.
Okay.
Yes, they do. But there are generic models and items online that you can find. So it's definitely possible to do all of this using first principles. We talked this morning about some of those sorts of issues for people understanding what's going on in a variety of different scenarios. So yes, it's possible for people to do that manually and to get good results. It just takes longer.
Yeah, I'm really encouraged by the fact that there is this aspiration to reuse, recycle, reuse products, because waste that has quite a high level of embedded carbon. It's not just the emission reduction that's delivered in use. You're facilitating ITS. It's not just the benefits that brings, but if the technology is going to cost a lot in carbon over their lifetime, then we're not really gaining anything.
Yeah, but I think, as an industry, traffic signals has made a huge step forwards in actually achieving much more efficient electronic systems, the technology itself. But I think I wanted to highlight the issues that surround the actual civils infrastructure and using more and more modular and factory-produced items, because there's a huge amount of waste that happens when you start constructing stuff out in windy, rainy, snowy, muddy situations.
Yeah. Okay, thank you. Are there any questions?
Tom's going to give me one of his great questions. Thank you.
Tom Siddle, Four-Way. Have you seen any appetite from the kind of purchasers of traffic signals, local authorities, developers, to actually specify and assess, tenders from a low carbon point of view? Typically, you get quality cost to actually bring it into the quality element of things.
I don't think this is something that is at the forefront of particularly developers' minds at this point in time. But as I said, like the aspirations for national highways is very much there. So I think it's something that will spread to other client groups. It will have to. There will be mandated requirements at some point. So that will then get put into that sort of qualitative element for tenders. I think that's why we as a group need to highlight these issues and promote them, even just softly to start with, in order to actually get that sea change of attitude that is going to be needed. There isn't going to be a choice about this in a few years' time, so we might as well be prepared, get on the front foot, and actually have the whole industry, actually working to that, because it's to all of our benefits.
Okay, thank you.
Can you make it quick, please? Thank you.
Hello, thank you. Keely Franklin from ARTSM. Thank you for that. Just to make a statement here from our members' perspective, we have highlighted an issue in respect of halogen, and the uptake from halogen to LED has actually been not as vast given the potential savings that you've identified. And I wondered whether the block was more that there isn't a specific mandate for carbon zero, or whether it's simply that people are just waiting and waiting and waiting for old things to fall out of fashion before they upgrade, because it's more about replacing rather than not building is what I see.
I think one of the biggest problems actually within the industry is, we talked earlier about the modernisation funds, the 15 million that DFT made available, but the situation is there's a hell of a lot of old kit out on the roadside, and a lot of local authorities are so cash strapped they cannot afford to make those investments to replace items unless they physically blow up or catch fire or something, somebody drives through it. In fact, that's actually probably the answer to everyone's prayer, to get somebody to drive through it, because at least they'll get an insurance claim off it. But
Yes. Or as Paul said, make a lot better use of what you've already got.
No. So, that's if we take a pragmatic assessment of the situation, that is the problem. We need more investment to actually bring kit up to date as it is anyway, let alone then take the next steps forward. But like you say, the benefits of LED signals is well documented, provides all sorts of cost savings to local authorities. So that's a great starting point. But what I'm talking about here really is then what we do, the next steps after that.
Okay. Thanks very much indeed, Alistair. Can we thank him in the usual way?
Thank you.